research. Okay, Jimmy?
Hello, my name is Jimmy Huai, and I'm a graduate student in ETAD, studying emerging gamification. The focus on is user experience.
Very good. User experience.
Yes.
My name is Sharat Chandra. I'm a PhD student here. I'm interested in human data interfaces and cognition, sound.
Okay, Matthew?
My name is Natty. I'm a PhD student here. My focus is in computer graphics and computer game.
Yep.
And computer music.
Okay.
My name is Chuck Kimbuli. I'm interested in digital materiality.
Oh, digital materiality. Okay. Ellen?
My name is Ellen. I'm a PhD student here. I research emerging health technologies with focus on wearable, immersive technology, biosensors, and virtual reality.
I'm Jenny Huffenberger. I'm in the emerging media technology, and I'm studying political media effects.
In particular, she's studying Twitter right now in a very creative way.
Yes, I think that would be good.
Okay, Dr.
So-
Kang Zhang, we're delighted to have you lecture here today on aesthetic computing. Please, we're very keen to hear you.
Thank you very much, Roger. So, as I showed here, that I'm a computer science professor at UTD, and but my really passion is in art and design. That's why you see nowadays I do a lot of research related to art and design, like generative art, and but this is one topic that I'm very interested. That is how art and design would help computing, not the other way. Okay, I would introduce the concept. Actually, aesthetic computing, this word was coined by our colleague Paul Fishwick, and he had a book published by MIT Press, where Roger was editor for that series. And so I will just mention about that particular book. So today I will just focus on this particular topic, just called the aesthetic computing. And basically, I want to pose two questions. One is what aesthetics, or in general, that includes art and design, what can they do for computing activities? The second question is, can computing or computer generate aesthetic forms, and if so, how? Right. So actually, we're talking about two directional fields, and one is actually from art design to computing. The other is reverse direction. As I am interested in kind of visual thinking, I present this conceptual framework in a sort of 2D fashion. So like this two-dimension here. So from left is computer science, and right is arts. And bottom is theory, and the top is application. So we have the spectrum this way, from technology to art, and then theory to application. So we start from the lowest, which is a algorithm, and of course we could think that we could go lower to math, right? It's more theoretical, but it's less relevant. That's why we start from algorithms from that end, and then so two related fields that I will eventually connect to art are image processing, computer graphics. That computer graphics is a class I've been teaching for quite a few years. And then from computer graphics, the typical and the successful application is computer-aided design, we all know, right? So that is a very application-oriented. So it's up there. And then from image processing and also using computer graphics techniques, we could have GIS, Geographical Information Systems. At UTT we also have a department, GIS department, that I also loosely involved in that Um, and then scientific visualization, that is basically using computer graphics techniques. That means we want to visualize scientific activities such as physical phenomena and chemical reaction and so on. So they are related to specific, scientific events or the entities. Later on we'll see a different or similar area, which is information visualization. But now then, using algorithms, we could conduct graph drawing. This is a specific area in algorithm and computer science. We call it graph drawing. That means whether you can design an algorithm to automatically lay out a particular graph, node edge diagrams, and in such a way that it looks pleasing, aesthetic. Say, a minimum number of crossings and no node overlap and so on. So that, I colored that way, that's GIS and graph drawing. So the colored nodes are the areas I have worked on that I'm interested. And then from graph drawing, we could apply to one area called software visualization. Software visualization refers to how to understand software development activities and also software components, their interactions. We try to visualize them. These different components, how they interact graphically. So that is also an area. Actually, I also do research in that particular area as well. And then from graphics, we all know that this is gaming and a very popular topic, and a lot of the kids like to develop from there. And then towards this side, then we have information visualization. That will be the actual focus that I will discuss more about that. That's the area I recently heavily involved in that particular research. And then from this side, we have visual arts. So we put visual arts here so that we are not discussing music here. So because everything we talk about are actually about visual, not quite the audio. Here. So the visual arts on this end, and then this is non-photorealistic rendering. In computer graphics, probably you have used that kind of a software that you input a photo and that software automatically convert it to cartoon, convert to oil painting or watercolor kind of a style, right? So that is the traditional technique called non-photorealistic rendering. And more recently, it's becoming very popular with deep learning AI approach using convolutional neural networks, so CNN. And those basically, you have probably seen recent articles that you input, say, Van Gogh's painting and as a style, and then you input your photo. And then the output is your photo transformed into Van Gogh's impressionist style. So, and we have seen recently a lot of this, but he has been successful with impressionist kind of painting style, but not quite with other styles that I'm also interested to pursue. Then on top of this, we have abstract painting, and that is what I'm interested, and using a computer to generate generative art, so we can generate abstract paintings more easily than representational paintings. And then graphic design. That's what I'm interested as well, about logo design and so on. That basically also can borrow the techniques from abstract design, painting as well. And also the information visualization can actually borrow a lot of techniques from graphic design. in terms of layout and color usage and so on. And then on top of that, we have the industrial design, which is more applied over there. So then we introduce the new interdisciplinary area called aesthetic computing, and blue in this direction. So that means the visual arts help the computing activities, and also help with the deep learning, help with the abstract painting, also help with deep learning, as well as graphic design, help the information visualization, and in this direction. And also, I draw this a little bit thicker, so because I'm going to talk a bit more about this. Abstract painting and helps information visualization and how they are actually relevant. And then in this direction, I draw green in reverse direction. That means using the computing or algorithm techniques to generate aesthetically pleasing kind of forms. And so this is generative art, including generative art, and so on. So this area is called computational aesthetics. Computational aesthetics, like using image processing techniques that we basically do the neural network deep learning. And then let's look at the definition. The application of the theory and the practice of art to the field of computing. So this is the definition actually by Paul Fishwick, and there are 3 example activities, including how to represent programs and data structures with customized and culturally specific notations. But so far, actually, we haven't really done much in this. For example, I mean, the programmers in China, when they program the notations and whatever, they might prefer different from those who are here, right? And with a different cultural background, they may want to program with different notations. And the second one is to incorporate artistic methods in typically computing-intensive activities, such as information visualization. So this is actually the main topic I'm going to talk about, how to actually use the theory and the practice which have been successfully used in art and design to apply to information visualization. And then